aspect that I have in my life. So it's for fun. So feel very free to respond. Don't always be don't always feel like you have to get it right every time. No. That's the best way to learn. So as we look at the questions, feel very free to just give a response. What your view is. That's all. That's the way you learn. You don't learn by just observing and being quiet. Okay? So be actively involved in the discussion. I already know how to answer these questions, so if you leave me to answer them again, I'll just be learning alone. So we'll start now. We'll start. Um, I want us to solve as many questions as we can. Last time you guys weren't that ready. So we'll look at 2. I hope you're ready. Are we ready?
Yes, we are.
Okay, let's get started. Okay, so for the function f of t graphed here, we need to determine the limits or explain why they do not exist. Okay? So what's the limit for a? We are told the limit as t approaches -2. So I'll give an explanation one more time. When you're given a limit, I don't know why my voice has gone again. When you're given a limit, um, it may be x, t, but the limit usually refers to the x-axis. So when you say t approaching -2, it means what's the value of y as x is approaching a given value. So when you say what's the limit as t approaches -2, it means what is the value of y as our x is approaching -2. So as we are approaching -2, this point, what's the value of y? That's what it means. Not necessarily the actual value of y, but what. Okay, let's just think of it in that way. Yeah. It doesn't matter whether a function exists or doesn't exist, but what value of y are we getting closer to as we approach the given value of x? So now you people are joining late. You're now disturbing me. So please let's ensure that we join in for the class on time. Okay, let's move now. Okay, so for A, yeah, what's the answer there? We need to determine the limit as t approaches -2. Yes?
Kindly repeat.
For A, what's the answer? The limit as t approaches -2. Okay, somebody says the answer is -2. Anybody else?
0.
Okay, so now I told you last time, make sure you add an explanation to your answer so that I don't ask you back. Yeah? Winner, you can start since you're the one who gave us a first answer. Why did you say -2? Well. That's the question. The question is telling us. The question already tells us that. The question tells us we are approaching negative 2 from both the negative and the positive side. In terms of x, now we need to find y as we are approaching that negative 2 on the x-axis. That's what the question is always been when dealing with limits. So we look at the value of y as we are approaching a certain value of x. I don't know if that does make sense.
Sir,
Yeah, yeah.
when I'm finding my value as zero also.
Mm-hmm.
Find it here because they say they're telling us to find the limit as x approaches negative 2. So, for me, when I look at the situation, because we have to look at when x approaches negative 2 at the left hand side of negative 2 and also at the right hand side of negative 2.
Yeah.
So, if I'm looking when it comes from the left hand side of negative 2, it's not like we're going from where this graph starts from, which is like negative 1 and
Calm
goes all
down,
the way to
calm down, calm down, and just explain slowly, slowly, slowly.
yes. So found zero because you have to find okay the limit as x approaches negative 2 from both the right hand side of negative 2 and the left hand side of negative 2.
Mm-hmm.
So we can start from the left hand side of negative 2.
This way.
Why this graph ends from is negative 1. So you have to move from negative 1 going upwards approaching negative 2. So when you're approaching there, the value is 0 because the point there, the whole, is on 0. That means y is 0. Then when you're approaching from the right hand side of negative 2, you're also moving from negative 1 going up to a negative 2. And the value is also 0. So the overall limit as x approaches negative 2 is 0.
Wow, wow, wow. Okay, thank you very much. I appreciate. So one point that I want to make one more time is this: whenever we're talking about the limits. If we say we're approaching negative 2 as we are in that case, which is somewhere there, negative 2. So if you saw what she was saying we are in reference, she was giving a point in reference to negative 1 to say we are moving from negative 1 in terms of y. So in terms of x, when you want to determine the limit as we reach that point on the x-axis, what we're interested in is what value on this y-axis. That's what the limit is. The limit is a value on the y-axis. So you ask yourself, as you are moving from the negative side, or the left side as she was calling it, as you approach negative 2 on the x, you've approached negative 2. Now ask yourself, what's the value of y? Okay? And then you also check the positive side. As you approach negative 2, what's the value of y again? So they are all referencing what? The x-axis. So the x-axis y is equal to what? So the limit is always a value of y. Take that, very important. So have we gotten that point?
Yes, we have.
Okay. So I can move to the next one. B. Let me see if you've gotten it. I'll allow Lena to be a bit quiet about it, and then let's hear from Joy and the others. Okay, so what's the limit as t approaches negative 1? Why is it negative 1, Sarah? Why are you saying it's negative 1? Yes?
She's explaining when you look at the graph as x is approaching negative 1, the y value is negative 1 as well.
From where?
From the negative side.
So from the negative side, so from the negative side, this is us. We're approaching what?
Yes.
So when we say we're approaching negative 1, first of all, the way I like putting it is, I'll draw a line on negative 1. This is our x-axis. So how are we approaching that line? So from the left, this is us coming to that line. Let me use a different color there. So this is us approaching negative 1 from the left. Okay? This is where we've reached at negative 1. Now you check the value of y. It's what? Negative 1. If you check the right hand side as well, we are approaching the same point, negative 1. So therefore, the ultimate value of y as we approach negative 1 from both the left and negative side is what?
It's negative 1.
Okay. So I didn't want you people to confuse it with the negative 1 on the x-axis. We are focusing on the y part. Okay, let's go to C.
But sir, you haven't said, is it continuous or discontinuous?
And if it exists or not.
What do you mean if it exists or not? What? All right. Okay, so
But the question is saying,
what's the question saying?
beside the limits, you also explain why the limit exists.
Imwe. Read the question correctly. It says, find what? Or what?
Oh,
The following.
Or?
Why they do not exist.
So in a case where the limit doesn't exist, you can't find it. So why should I explain why it doesn't exist when it does exist? So all the ones we've looked at so far, they are existing, in short. That's what I'm trying to say. Okay? Now, one more aspect. Let's add to say determine whether continuous, like somebody wants us. I think Sarah wants us to talk about continuity as well. So, can we say the function is continuous about the point negative 2 to start with?
no, sir, it's discontinuous.
Why is it discontinuous?
We explained last time with an conjunction.
Is that the point you're going to give in your assessment?
I tried to explain, sir, but you can see it in that way as well.
Yeah, especially in a case where we don't even require you to give an explanation, you can think of it in that way. Yeah, but you convince your tutor by saying, yes, okay, remember what I said about the mathematical way of expressing that. When is a function continuous?
Sir, you said that the function is continuous if the circle is closed because the y value exists, something like that. But I'm not sure.
Ah, thanks for adding that point at the end. Okay, so she has put in the value of y. I like that already. That's one of the points. So there are just two conditions, actually. Two conditions. If you want to know mathematically if a function is continuous, first of all, the limit should what? Should exist. So when the limit exists, the function should also what? exist. Those are the two conditions. Okay? So for the first one, we say the limit does exist. And the limit exists if two conditions are satisfied. The value from the negative and the positive side is the same. So we saw that the limit there is -2 from both the left and the positive side. So we are satisfied. The limit is 0, right? Now, what's the function value? In short, what's f of -2? What's the value of y? In other terms, at that point. So if you are plotting -2 comma what? What's the answer?
0.
So I told you when it's a circle there, it means there's nothing. So we don't have any point on -2 for the y value of the function. So does not exist. This is where the open circle and the shaded part was coming in. So the people were, yeah, Sarah and Joy were actually right. So that's the issue of putting it in the mathematical way. Okay, do we get it now? If you contain the difference between the limit and the function value.
Yes, sir.
All right. Let's look at B. Is it continuous or discontinuous? About the point -1. It's what?
Continuous.
Why is it what? Okay. What's the function value? F of -1 is what? So check -1 is comma -1. It is shaded, so the function exists. What's the limit? The limit is what?
The limit is -1.
So -1. So this is what I said mathematically. For a function to be continuous, the function and the limit should be the same. So it's continuous. Now let's go to C now. Okay. What's the limit as t approaches 0?
0.
Joy says 0.
0.
Tasha says 0. Is Tasha Natasha or they are two different people?
I'm Natasha.
Okay.
The same person.
Alright. So, others, are we all saying it's 0? It's 0. Natasha, make a comment on why you're saying it's 0. The limit.
Because when you approach it from both sides, then it's giving us 0.
Okay, so for any information, from the left side on the function, if we're approaching 0, I can see us moving like this. That's what we're approaching. And then from the other side, from the positive side, that starts approaching. So I don't know how you are saying we're approaching 0. Because we are looking at the value of y. That's a limit, value of y. So you look at where the function is, okay, as you approach a certain point. That's the way you determine the limit.
So side does not exist. The limit does not exist. That's what I found.
Huh? What are you saying?
I'm asking, so the limit exists or it does not exist?
It's not to ask me, it's to tell us what you think, Kai. Anybody would want to respond? By now, guys, you should have built confidence about this, yes?
The overall limit does not exist because the y value that we're finding from the left hand side of 0 and the right hand side of 0 are different.
Mm-hmm.
The other one is -1 and the other one is +1. So that means the overall limit as t approaches 0 does not exist.
Thank you very much. So, the limit as t approaches 0 from the negative and the positive side are different answers. So, on the function from the left side, this is us approaching -1, the value of y. Then from the positive side, we are approaching 1. Now, some of you are asking a question, how are we approaching 0 like that? 0 is the y-axis. That's one thing that you should know. So I said when you're approaching a point on the x-axis, just draw a line. So we've drawn a line. So the function tells us we're approaching it at 2 different points. So when the limit from the negative and the positive side when they don't match, we say the limit doesn't what? So that's why they said explain why they do not exist. So the limit doesn't exist because the limit from the positive and the negative side are different. You can even show it just like I've put it. You write that first of all, you write this, and then you say, we are using mathematical language. You don't want to write sentences, so not equal. So we can just say limit does not exist because, yeah. So would you say a function is continuous or discontinuous? Margaret, make a comment as well. Okay. Let's allow Zawelanji to make a comment.
So on this one, I'm not very sure.
Okay, don't leave the meeting because I'm mentioning the names, please. Okay. We can hear from Mark then. Mark and Fishoys.
Yes, I think it doesn't exist. I mean, it's not continuous because we haven't found the limits to be the same, so we can find the function.
Okay. Good. Because now you've added a point that's not true. You're right, the limit doesn't exist. So the fact that limit doesn't exist, we are sure it's not continuous. Now, it doesn't mean we can't find the function value. We can find the function value. So what's f of 0 if you look at the graph?
0, 0. F of 0 is 0.
Okay, so we can see there is a point on 0, so it does exist. Now the limit doesn't exist. So it was only going to be continuous if this went like that, and then that also came like this, meaning that they would all approach 0. The function would also be 0, so it would exist. It would be continuous in such a case. No, okay.
So, sir, I just want to clarify. The function does not depend on the limit, not at all, right?
They don't depend on each other. That's why you saw in this case the limit was existing, even though the function wasn't existing about that point, but the limit was still there. Here we've not found the limit, but the function is existing.
Okay.
And then the limit as t approaches negative 0.5. So somewhere there. What's the limit? Miss Chumbula, give a comment there. What do you think is the limit as we are about negative 0.5? We are waiting to hear the truth. Okay, anybody else? Anybody who is willing to give us an answer there?
-1.
Why do you say negative 1?
Because if you are moving from the right hand side in the y-axis is -1, and from the left is -1.
Okay, good. So if you draw a line here on that point, and then you look at the function from the negative side, this is where we are approaching from the right side, so we are just on the same point, -1. Okay, good. So would you say it's continuous or discontinuous?
Discontinuous.
Why do you say it's discontinuous?
Because the y-axis is the 4.
Okay, Lena, would you say it's discontinuous or not?
This Avisa, I'm not sure. Okay, for me, looking at it from now, I can say it's continuous because the values that we're finding, there's no hole in between. I'm not sure, sir.
Okay, so there's no gap there. You don't look at the what? Look at the actual point that you're focusing on, Margaret. So about this point, there's no O there, so it's continuous. We are it's continuous. It's like moving. Don't focus on other points around it, but focus on the actual point you're talking about. Negative 0.5. Okay, so we are done with question 2. I think we can look at the last graph question now. So let's move very fast now. This time around, I want to hear from Taisia, Chikondi, Blessings, Joshua, Mubanga, Chama, Pexina, Petra, Trufena, Weni. Yeah, let me hear from you people. So here is the question, yeah? Yeah. Can you see the graph?
Yes.
So which of the following statements about the function is true or false? Okay. So A says the limit as x approaches 0 exists.
False.
So Blessing says it's false. Why do you say it's false? Just add a comment to your answer.
This is because we're able to find the limit, but for the function value,
So now if you look at your reason again, the A is saying the limit exists. Give it a try again.
okay, yeah, I just missed. I thought I was in a large, I thought it was
Okay. Do we all get why the limit exists about that point? So you've seen why it's important to add the reason to your answer, because if you don't add the reason to your answer, you may actually get it wrong. So add the reason to your answer. Convince yourself why it exists. So why does it exist? Why does it exist? It exists because, yes. Okay, I will allow everyone to say something if you've got an answer, since people don't want to talk.
The limit exists because if you look at the graph, x is approaching 0. Sorry, as x approaches 0 from both the left hand side of 0 and the right hand side of 0, the y values because it's on the x-axis.
Okay, so that's okay. B, the limit as x approaches 0 is 0. Is it true?
It's true.
C, the limit as x approaches 0 is 1. So that's disagreeing with B, right?
Yes.
You're not even confident. It's contradicting the previous one.
Yes.
And then D, the limit as x approaches 1. So why is 1? 1 is here. So let's try to observe how we're approaching that. From the left side, this is us approaching 1 from the left side. From the right side, this is us approaching 1. So is the limit 1 there?
No, sir.
So I want you to give me the limit from the, what's the limit from the negative side when we're approaching 1? What's the limit?
Negative 1.
Negative 1.
From the right side, what's the limit?
0.
Positive.
Okay,
0.
good. So this is not true. The limit f of x is 0. Is the limit 0?
No, sir.
Maybe before we denounce all these answers, what's the limit? What's the limit as x approaches 1? Mm-hmm. Yes?
We are having 0 and negative 1 then, sir.
So what?
That's our limit.
We just need to have one limit. We can't have two. Oh yeah. So when they don't match, it doesn't exist. But you can separate them, the left and the right hand side, 0 and negative 1. So the limit itself doesn't exist. And then F says the limit exists at every point C between negative 1 and 1. Let me first of all go to G. G says as x approaches 1, the limit does not exist. Is it true?
True.
Okay, so we've already talked about that. True. Let's now answer F. The limit as x approaches any point C exists at every point between negative 1 and 1. Now you ought to be very smart about this. You ought to be very smart about it. The limit exists at every point C in negative 1, 1. Is that true? What that means, by the way, it means between -1 and 1, any limit that you can try to find in between does exist. That's what it's saying. Is it true?
Sir, it's not true.
Why is it not true? Could you give a point which is not a limit which doesn't exist?
The same limit as x approaching 0 equals to 1. For C and E. We found one needs to exist.
Okay, so now this is now why you need to understand these brackets.
You mean not included?
So what are you saying?
For me, for every point, yeah, they do exist between -1 and 1. For example, we had the limit of f of x when x approaches 0.
Okay, I like the way you guys are thinking. So the limit does exist at every point between -1 and 1, in that any point that you're going to pick, the value from the positive and the negative side is the same, except if we use these brackets, it wasn't going to exist, because we know that at this point the limit is differing between the left and the right hand side. So one comment that I want you guys to pay attention to is, whenever the lines are continuously joined together, wherever there is a dot somewhere, the limit exists. Okay? Whenever a line is joined, solid lines like this, any point in between here, the function is continuous. Even here, continuous. So a function is not only continuous when there's a open dot there. When there's a separation like that, it's not continuous. What are some of the tips that you should know? Any question? Is there any question? I believe all these are questions you're able to answer. Right? No issues there. Equally, all these, you should be able to answer all these with no queries. All these you should be able to answer. So there's this question. I think we'll end with this one. I didn't actually teach you the limit rules, but you've been applying them. Alright? So what does the question say? Suppose the limit as x approaches f of x is 1, That is negative 5. Name the rules in theorem 1 that are used to accomplish steps A, B, and C. A, B, and C. Let's try to name them. So if you check what's on the left there, what have we done for us to get to? So you've seen that we've distributed the limit. When you have the limit as x approaches 0, then you've got a function f of x divided by g of x. You can distribute the limit to the top part and the bottom part separately. Okay? So if you can divide their results, then you found the limit, the overall limit. That's what the idea is there. So I believe this is called the quotient true. Okay, so you can call it the quotient true. I hope I'm right. And then from there, we can see that the top part, we've what? We've distributed according to the sign there. So we call that the difference rule. Yeah, and then on the bottom, there's nothing that has happened. And then from this point to this point, it's still the same, right? So now you've pulled out these two. I think we call that the coefficient true. Whenever we've got a limit of a function, when there is a coefficient, I can pull it out. Let me take you to the rules now. I think you have an idea now. Actually, I thought of teaching, but I was like, no, I think I should just talk about it after we've learned everything already. We'll be able to see them in practice. I think it's right here. So it should be somewhere, just yeah, there. Are we able to see?
Yes.
Okay, so for the sum, you've seen that whenever you've got like an addition of two functions, you can actually separate them. Right? So we call it the sum rule, the difference rule. I think this was supposed to be not I called it the coefficient, but it's called the constant multiple rule. Okay, so constant multiple. Where you've got a coefficient, you can pull it out. And then the product, whenever you've got a product of two functions, you can separate them as a product of the limits. The quotient, I'd explained, the power. So even when you've got a power as well, it's somewhat interesting that you can just simplify whatever is on the bottom and then raise it to the same power. The root, you can just actually substitute the limit directly there and maintain the power. Anyway, you get the idea. These are not even important unless they ask you to state them, but they're just like, these are basic things you can just look at and okay, yeah. Do you have any questions? Any questions? Okay, so when can I give you a quiz? Yes. When are you guys going to be ready for a quiz? Because I'm going to include even the definition of precise definition of the limit and everything else we've learned under limits. Would you be ready to write the quiz tonight?
No.
Why no?
No.
No.
Why are you saying no? No, Sunday is too far.
I am behind.
but it's a quiz, it's not a test.
We'll tell you when we're ready, sir.
No, that's not the way I work. Okay, so since you refused tonight, you're going to write a quiz for math tomorrow, Friday, at I'll allow you guys to choose a time. You can write at 10, you can write at 15, you can write at 16. Choose any time that's comfortable. Just right now, let's vote. Which one is more which one are you more comfortable with? If you say you're going to write at 10, it means you're going to write immediately after the chemistry class. 13, you've got a few hours at least. 16. Okay, somebody says 16. Others?
16.
16.
16.
Yes.
Okay. So you have a quiz tomorrow at 16, and you only have, I'll give you only 40 minutes. Okay. You will not have more than 5 questions. Alright. And then chemistry, you write the quiz on Saturday. So how many EIS, dear? Okay, so winner is an Adventist. So to be fair enough, since the physics tutor stole my time the time I was sick, you not learn physics in the night. Do you even have classes on Saturdays, by the way?
Yes, we do.
Yeah, so I'll get the evening class because you stole my classes when I was sick. So we'll have a quiz on Saturday night for chemistry at 21. Okay, take note.
Sir, kindly upload this class so that I should try to revise on what we learned.
No, there's nothing like that. Just solve questions. Watch other videos. You've already learned this. Just solve questions.
I wasn't getting training this time.
Uh, so I don't know if the recording was recording the voices of people